Yes, students, let us revise in short what we have studied in solid state chemistry. Now, as you know, solid state chemistry is all about solid state. So, we have studied different types of solid state. We have studied how they are arranged, what are their different arrangements. So, basically, in this chapter, we have focused upon the arrangement of the solid systems, right? And why are we so much interested was we saw that this arrangement of solid state led us to different properties of solid state. So to understand different properties of solid state so that we can apply them in our future or for betterment, we need to study their arrangement, how different atoms of solid state are arranged. So for this, we studied in the chapter something about unit cell, something about crystal lattice. So if you remember, we had started with different types of solids that were crystalline and amorphous solids. There also we further subclassified the crystalline solids. Then we went on to arrangement of different particles in this solid state. So students, if you remember, we had studied this unit cell. Yes, students, you remember this? This image shows a unit cell. Now, a unit cell is what? It's a simplest division of a crystal lattice to say. So here, this yellow colored spheres are nothing but the atoms or particles or ions, whatever they exist in which state. So this is a unit cell if you remember. And as I told you, we can join the unit cell to form a huge network. So every solid state, every crystal has many unit cells joined together, and they form a large network of the solid. And if you remember, we had also seen different types of crystal lattice. We had seen a different arrangement of the spheres in crystal lattice, and also we found out their coordination number and their packing efficiency. So this is your unit cell. Now from unit cell, we also saw that there are different 14 types of crystal lattices possible. So as you remember, these crystal lattices are known as Bravais lattice. So according to Bravais, we can arrange the particles of a crystal into 14 different types. Now if you remember this 14 types, how we got this 14 types? We got this different 14 types based on their axial distances and axial angles. Yes, remember students, axial distances are nothing but your all the three dimensions. Like here, this is your one dimension, this is your x axis, your y axis, your z axis, whatever it is. So when this distances, this different three different distances we measured, remember we denoted them as a, b and c. So these are your axial distances and the angles between the axes. For example, here I am marking, can you see I am marking an angle over here. Again you have a angle on the back side, the third dimension. So remember this angles we named as alpha, beta, gamma. So these were the axial angles. So depending on different values of a, b, c, alpha, beta, gamma, we have this 14 different Bravais lattices. And also we shared the chart of the textbook. We studied with the chart given in the textbook. So you all have to remember the names of these different 14 Bravais lattices, that is tetragonal, monoclinic, orthorhombic, etc. So yes, there were 14 different Bravais lattices. Okay, then also we saw something about different types of cubic system. For example, in a unit cell, there can be, as you can see, there are three types which we saw. That is simple cubic, BCC that is body centered, and FCC that is face centered. So in simple cubic, if you see, there are 8 spheres at the 8 corners of the cube. You remember this, we have studied already. Also what we have seen in the body center, next we move, is here at the center of the body. Can you see a gray colored particle, it may be atom, it may be ion. So it is placed just at the center of the cube. So such a type of system is known as a body centered cubic system. And when I have atoms at the center of the face of each cube, that is each face of the cube, there are six faces in a cube, and if each face of the cube has a particle at the center of it, it is known as face centered. So I hope you understood the difference between this. We have seen that in simple cubic there are no particles at the center. In the body center there is only one particle or atom at the center, whereas in FCC face centered there are particle at each of the center of faces of the cube. So this were the three types of different cubic system. We have also seen, as given here, the efficiency of all the three systems. You remember we had seen that FCC has the best packing efficiency of about 74%. We had seen this, and also we have derived the formula, the packing efficiency. Also we have seen the coordination number. Cn represents the coordination number. Remember, coordination number is what? The minimum, the atoms, the maximum atoms which a given sphere can touch, or the number of neighboring atoms a given atom touches, in which are present in its neighboring atoms, is the coordination number. So we had also discussed, we had also derived different coordination numbers. So these were the basic concepts which we had studied in the solid state chemistry.